and we're going to talk about epigenetics, I believe, Richard. So I'm going to hand over to you, sir.
Fantastic. You've called it an epigenetics masterclass. Look, it's hardly a masterclass. I'd class this as more of an introduction. As you guys know, I love going into the science, but epigenetics can be such a rabbit hole of information, pretty much the same when it comes to all areas of nutrition and bloods and so on and so forth, Steve, as you can attest to in regards to getting into the minutiae with bloods. But I'm going to share my screen. This is a basic introduction to epigenetics. If you don't know what epigenetics are, by the end of this, you will be able to explain to somebody in simple terms what it is while having a fairly good understanding yourself. So let's have a look at this. Present. Select the correct window. Okay, apologies. I'm going to keep it on presentation view there so I can see which ones are coming up next. So yeah, it always helps, doesn't it? So yeah, look, I'll start with this. Many of you know where I've come from previously. So look, I used to be clinically obese, type 2 diabetic. I suffered with daily debilitating migraines, chronic fatigue, depression, anxiety. These migraines I'd suffer with every day. They would make me blind, and I was on 3 different medications for this. I also suffered with things like high blood pressure, severe acne, depression, anxiety, all of these things which were all encompassing and took over my life. I believed that this was a fact of life. I went through spells of consuming foods that I knew were not good for me, such as fast foods and processed foods and so on and so forth. But I did actively try to eat healthy. And when I was trying to eat healthy, this is pretty much what I was consuming. I consumed food from the Eat Well plate and the food pyramid. I predominated grains. I consumed my muesli for breakfast with my chopped up banana. I was doing all the things that I was meant to be doing. I was avoiding my saturated fats and cooking in vegetable oil. But I remember the days I'd go through the supermarket and I would actively be picking up sunflower oil, thinking, I was super intelligent and I knew exactly what I was doing with my health. Unfortunately, this was the result. So I actually put a further 3 stone on top of this. And in fact, the image on the right there, I had to drop 3.5 stone in order to do that parachute jump for charity. It was a tandem parachute jump, and I signed up to do this with my sister. So my sister had an instructor and I had an instructor. And this was the turning point for me, because when my sisters are absolutely tiny, my sister is a different father. She's absolutely tiny and she weighs next to nothing. And her instructor walked into the room, and he was a fairly large gentleman. And they explained that it needs to be a weight distribution in regards to the parachute jump. And then came in my instructor, who was this tiny little guy. And I was scratching my head thinking, well, if this is true, why have I got this tiny little guy? Why haven't I got some big guy coming in as my instructor? And the instructors looked at one another as if to say, well, how do we tell you that you're fat, And I was clinically obese. As I say, in my mid-20s, I could barely walk up a flight of stairs. And I worked incredibly hard to drop this 3.5 stone to do the parachute jump, which I did, by the way. And I raised a lot of money for charity, and it was absolutely fantastic. But I put all that weight back on, and a super long story short, and I won't go on too much of this because you guys know much about my story, but I made a change to my diet. I changed my diet. As you guys know, I became ketogenic and then carnivore. And within 12 months, I'd lost 107 pounds. I was no longer in a diabetic range. I was migraine-free, full of energy, pain-free, depression, anxiety-free. All of these things that I suffered with went away because I changed what I put into my mouth. I wasn't calorie counting. In fact, I was probably eating more from a caloric perspective than I ever was prior to this. And all of those things occurred. Now, that picture, for full disclosure, did not happen in 12 months. And this will follow into the question, Stephen, that you asked me before we came on in regards to set points. And we'll get into this as we go on. But that was about 4 or 5 years after. And it did take a lot of hard work and a long time to get to that. But I've used the picture because I like it. And it's something I'm very proud of. So as my diet continued and I decided to pursue the career further in bodybuilding, I managed to gain incredible amounts of mass despite consuming carbohydrates. I became incredibly big and eventually went on to become British and European champion as a professional. So I was number 1 in Europe as a professional bodybuilder in men's physique bodybuilding. So I went from being unable to walk up a flight of stairs to being the number 1 athlete in Europe within 4 to 5 years. As you guys know, I'm considerably smaller. I've gone into running. This is me fighting for my life when Mikey Davis, good pal of mine, who's the number 1 athlete in Europe in Ironman, by the way, and recently completed the World Championships. He's now number 36 in the world. Ex-vegan, came to see me as a vegan. He's now carnivore. He competed in the World Championships last weekend, and he is now the Welsh record holder. He's the fastest Welshman ever to complete corner. There we are. And that's probably a talk for another day. But my point for this is I've gone into this, I lost a lot of weight, and now I compete in endurance sports, and this is why I've lost the weight. The diet has seen many changes, but I think that I look considerably healthier, on the left. And these photos were taken 15 years apart. Now, the reason I'm telling you this, and I'm going to skip some of these, is that many would think that I'm genetically gifted, because when I was competing, I achieved some incredible things. My weight was 2.3 kilograms of fat. So my whole body weight was 2.3 kilograms of fat, which is ridiculously low. My body fat percentage was 3%. This is incredibly low. I'm actually lighter than this now, considerably lighter, believe it or not. But this was when I was competing and at only 3% body fat. And when I competed, I was probably closer to 2%. Now, this isn't healthy. And again, we'll get into this later. But genetics. You can't change your genetics. Your genome is there and you cannot change it. Your DNA is set and you cannot change it. And many of us will resign to this fact, saying, well, it's in my genes, it runs in my family. Well, this is where I came from. This was my father genetically. He wasn't a father in person. He left when I was 3, so I didn't know him incredibly well. Despite only living a few miles down the road, he didn't want to know me or have anything to do with me, which is a shame because he died fairly recently at 62, and of a heart condition, which is something that happens in my family. Again, something we put down to genetics. Now you can see, if you look in his face, you can see me in there. This was my fate. This is where my genetics were taking me. How did I achieve such incredible things, such low body fat, and becoming number 1 athlete? Can you imagine this guy becoming number 1 athlete in Europe? Because this is technically me. If we believe that we are governed solely by our genetics, then this means that things that we feel and want to be achievable means that they are absolutely unattainable because we're governed by our genes. And I don't resign to that fact. And in fact, I would argue quite the opposite. And it's epigenetics that allows us to overcome these things. So what are epigenetics? In simple terms, most of us only access a portion of our DNA. And if you don't know anything about DNA, it doesn't matter because I'm going to explain as we go along. But epigenetics allows us to flick the switch, if you like, to access the best parts of our DNA. And again, if that doesn't make sense, we'll as we go along. So these are our chromosomes which are found in the nucleus of every cell in the body. So every single cell in your body contains, minus the cells that don't have nucleus, by the way, contain these chromosomes. Now, if we were to tear apart these chromosomes and unravel them, it would create this. So as you see, that there's a chain there. So I'm tearing apart the chromosome. This is called the chromatin. The chromatin is our DNA, which is wrapped around these groups of proteins called histones. Now, histones are groups of proteins. There are 8 in total, and they come in pairs of 2s, but they're tightly bound together. Now, this graphic it's not accurate in the sense of looking through a microscope. I've done this for simplicity, but just imagine that your DNA is over 6 feet tall in every single cell. If you were to unravel the DNA in every cell, it would stand over 6 feet tall, which is absolutely incredible and mind-boggling, and I can't even comprehend that. But this is how we fit the DNA into the cell. It's wrapped tightly around these groups of proteins called histones. And that's how we compact them into the cell. Now, the DNA is really important because every day we take photocopies of this DNA in the form of mRNA, messenger ribonucleic acid. And this is what this is on the bottom. And if you see on the bottom there, there's 3 little pillars. And these pillars are called nucleotides, and collectively they're called codons. So just remember that code. So as this is sent, or as this photocopy takes place every day, countless amounts of times in your body, this photocopy is then sent to another part of the cell called the ribosome, a machine, if you like, that reads this code. And that's what I've put there for simplicity purposes, a machine that reads this code. And as this mRNA passes through this machine, it reads the different code, these codons on there. And each code will signal the transfer RNA, the tRNA, to pull in an amino acid. Now, you don't need to understand what this is, but in simplistic terms, every time we consume foods like proteins, animal proteins, or plants, whatever it may be, these are broken down into proteins. These proteins are then broken down further into amino acids. So we consume protein, they're broken down into amino acids, then the body, through this process, will make new chains of proteins to allow us to heal and repair the body. And this is what happens in the ribosome. So each code will signal a certain amino acid until these amino acids build a chain called a peptide, and then these peptides go on to create proteins. And that's what these little things are on the left. These proteins go on to do everything in your body. They make your eyes, your muscles, your kidneys, your liver, your heart, your brain, cells, nerve cells, lung cells, everything that goes on in your body is made from these proteins, which originates from these photocopies of DNA. Does that make sense? So in simplistic terms, we consume protein. These proteins are broken down into amino acids. Then via this mechanism, which is protein synthesis, so you guys may have heard of people talking about muscle protein synthesis and protein synthesis, and many people don't understand what that is. This is what it is. Once we've broken down the proteins into amino acids, these photocopies will build series of peptides into chains of proteins which go on to heal and repair every cell in your body. Now, this is essential. This is what keeps us alive. This is what allows us to fight off viruses and infections and do everything that we need to do in our life. Now, in simplistic terms, each one of these histones, these groups of proteins, has a tail. And again, this isn't, if you were to zoom in under a microscope, this isn't what you'd see. I've done this purely for explanation purposes. But each group will have a tail. And in this case, I've referenced the lysine tails. And they do have others, but lysine tails on each group of protein. Now, these lysine tails will have a high affinity to certain enzymes. And two in particular I've mentioned here are HATs and HDACs. So HATs is histone acetyltransferase and HDACs are histone deacetylase. There are others. There are lots of others. These processes can occur via many different mechanisms in the body, such as methylation, which you guys are familiar with, DNA methylation, phosphorylation, ubiquination, so on and so forth. But for simplicity purposes, I'm just going to speak about acetyltransferase. So what happens is these little tails there, these white tails, these lysine tails, they attract these enzymes. And in this case, I've added a HDAC. Now, again, you don't need to understand what it is, but when the HDAC binds to this tail, it causes the chromatin to tighten. So if you can see the groups of proteins, they're all closely linked together, which basically means that the DNA is no longer available for expression. So it can no longer make that photocopy that we've just mentioned in one of the first slides. But when we swap that HDAC for a HAT, it does this. The HATs open the chromatin. They relax the chromatin, allowing this DNA to be available and open for expression. So this is what we need to happen. We don't want the DNA to be clumped constantly. There are times that this can be beneficial, but for simplistic purposes, what we want is this DNA to be open and available for expression. So our body can decide on which parts of the DNA to photocopy to build specific proteins. Now, if it's in this state, the photocopies are going to be poor, which means it leads to ill health. We become sick. We're not creating the proteins that we need to heal, build, and repair and survive and to be fit and healthy. We need the chromatin to be open and available for expression. We need the HATs to be available and not the HDACs. So basically, what I'm saying with this is that we need to govern, or we can govern, which of these enzymes will bind to those lysine tails to either express and open the DNA so we can photocopy efficiently, or whether we allow the chromatin to be closed and therefore cannot express the DNA. Does that make sense? Thumbs up if yeah. Does that make sense in simplistic terms? So we want the DNA to be open and available for expression. Now, when we're sick or when we are consuming toxic compounds, the chromatin is closed. The chromatin does this, which is what we don't want. But the beauty of this, the beauty is that we can govern how much of this DNA is open for expression via epigenetics. And this is what epigenetics is. We can govern how well these photocopies take place. We can govern how much of the DNA is open for expression. And this is controlled predominantly, and I would argue more than this, This is from a study that I've put into this for reference purposes, but I would argue considerably higher. But we have the ability to change and express our epigenetics by diet and lifestyle. And that's incredible. Take a step back and think about that for a second. If you blame your DNA, it runs in my family, for all of your misfortunes, just imagine somebody tells you that, wait a minute, you can flick the switch to open your DNA, to allow it to be expressed at a higher level, so therefore you can become fitter and healthier. You can run faster. You can stop these aches and pains. This is exactly what epigenetics is. Does that make sense so far? Fantastic. So diet and lifestyle. So when we think of diet and lifestyle, we think of things like this. This is what we are told to consume to be fit and healthy. Things like broccoli. Broccoli is a superfood, allegedly. And I've put a title on there, superhero or supervillain. And I'm going to go in and explain a little bit about these compounds that are found in certain fruits and vegetables. And I won't go into too much detail with this, but I think this is important just to reinforce some of the things that we've been taught over the last few months. So coming into this, I want you to understand a few terms. Genotoxic. Genotoxic means damaging to the DNA, which we do not want. So this damages the DNA and prevents expression. So we don't want genotoxicity. And coming on from this, another thing that I want you to understand is that broccoli contains isothiocyanates. And this is from a Google search. Yes, broccoli contains isothiocyanates. Isothiocyanates are groups of natural compounds found in cruciferous vegetables, including broccoli, cabbage, and kale. They contain sulfur and contribute to cancer chemo preventative treatment. And this we'll go into as we go on. So that sounds fantastic. It sounds brilliant, doesn't it? Well, broccoli fights cancer. Well, brilliant. But don't forget, it contains isothiocyanates. And let's go on to this. This is a study that looks at the effect on juices from cruciferous vegetables. And I'll zoom in on this. The first line, genotoxic effects. And I'm going to read this. Genotoxic effects of juices are due to specific constituents of cruciferous plants, such as glucosinolates and or their breakdown products, in particular, isothiocyanates. Isothiocyanates, we were just told in the last study that these isothiocyanates were super beneficial. This study basically shows that the present findings clearly indicate that cruciferous vegetables contain DNA-damaging constituents. So in simple terms, broccoli damages our DNA. Therefore, we do not want to consume things like broccoli to allow us to access our DNA, our epigenetics, essentially. So what about broccoli for cancer treatment? Now, yes, broccoli can be used for cancer treatment, but chemotherapy also damages healthy cells. Chemotherapy hurts and damages healthy cells in the body and can lead to a whole host of problems. Now, when it comes to cancer treatments, the reason that this isothiocyanate is created is when we chew the plant releases these toxic compounds, which are defense chemicals. They're defense chemicals because a plant does not want to be eaten, just like an animal does not want to be eaten. An animal can fight back or run away, but a plant is rooted to the ground. So they contain these toxic chemicals, these phytoalexins, these plant toxins. So when we bite into this plant, the myrosinase binds to glucoraphanin and creates this toxin, this isothiocyanate, which goes on to cause DNA damage to the body. And this is where it helps fight cancer because it also damages DNA within the cancer cells. But the beauty is that if we remove these compounds and removed the compounds that caused the cancer in the first place, then we wouldn't need to consume these toxic isothiocyanates. So when it comes to broccoli consumption, the question that I would ask someone is, yes, broccoli helps fight cancer, but do you have cancer? And if the answer to that question is no, then why are we consuming broccoli? Because broccoli damages our DNA. And there are better ways to help fight cancer. But again, that's a talk for another day. So let's come into this. Now, I've highlighted these segments in white for a reason, the hypothalamus on the left. And then we look at the item on the right. And because it resembled the male genitalia, I thought I'd better label them. So this is actually the pituitary. This isn't something from the male genitalia. This is the pituitary. So when we create T3, thyroid, for example, it comes from the hypothalamus. Thyroid-releasing hormone goes to the pituitary. This releases thyroid-stimulating hormone to the thyroid. And then this goes on to create T4, and then T3. So this is an important process within the body. So just bear this in mind. Isothiocyanates affect thyroid and iodine uptake. These isothiocyanates, which are found in these cruciferous vegetables, compete for absorption with iodine, which prevents the absorption, which leads to goitrogens, therefore basically inhibiting our body's ability to create thyroid hormone. So in simple terms, if you suffer with thyroid problems, these isothiocyanates and other cruciferous vegetables are not for you. These are not designed for human consumption. Coming on to broccoli, sorry, kale, spinach. We get it in spinach. Spinach is incredibly high in iron, which it is, but we can't access this iron, and we'll come on to this as we go. But what spinach is incredibly high in is oxalates. Now, many of you guys coming into this space are familiar with oxalates. So what do these mean? Are they actually damaging? And there's many people within Layman Norton, for example, has said recently, and in various other things, that oxalates are not damaging. Well, I'm just going to show you the evidence so you can make your own decision. So if we look on the bottom right of this, that image there, the raphides, by the way, this is what oxalates create. Raphides, which are needles. These are needles which will then find their way into tissues within the body and joints, and they can cause a whole host of problems, by the way, and we'll get into this as we go. But if you look on the bottom right, we've got spinach taken and cultivated from different times throughout the year. Bottom right, we've got 614 milligrams, and this is per 100 grams, by the way. And at the top, we've got as many as 1,000. New Zealand spinach contains nearly 1,800 milligrams of oxalate per 100 grams. Now, in the UK, spinach is found in 200-gram pouches. So if we were to obtain or consume spinach from a standard pack within the UK, we'd be consuming twice this volume of oxalate. And oxalate can cause problems. So these are studies which have shown that oxalates induce breast cancer, kidney stone formation, joint pain, and it goes on to say that it causes lots of issues within the thyroid, which we've just mentioned. So not only do these cruciferous vegetables such as broccoli and cabbage cause these goitrogens, but now we're getting problems with these raphides causing issues within the thyroid. But let's take a step back. I mean, how much are we talking in regards to a lethal dose? So let's take a look at this study. So humans produce around 10 to 30 milligrams of oxalates via something called the glyoxylate pathway, which is a pathway that is created through the breakdown of glycine and hydroxyproline, which this occurs in the body every day. But we only create 10 to 30 milligrams. Now, bearing in mind, those figures that I just showed you are considerably higher than this. So let's look at this study. And let's look at the part that I've highlighted. The minimum dose of oxalate causing death in adults is 4 to 5 grams. 4 grams is 4,000 milligrams. And we've just highlighted that some spinach contains nearly half this amount per 100 grams, which basically means if we had a New Zealand spinach and 200 grams of it, that's 3,600 milligrams. That's almost enough to be recognized as a lethal dose in adult human beings. That to me is absolutely staggering and astonishing. Am I saying that if you eat a pack of spinach that you're going to die? I'm not saying this whatsoever. This is right at the lower end, and this occurs in people who are already unwell, who are suffering with insulin resistance and type 2 diabetes. But this is the majority of the people on the planet. Most of us are in an insulin-resistant state. Most of us are suffering with some form of illness already. Most of us are already sick and unhealthy. But the upper limit, 15,000 milligrams, is enough to kill any one of us. 15,000 milligrams. So bear in mind, even the lowest one that we looked at there, which was 600, which would be 1,200 milligrams, that's a considerable amount of oxalate towards something that is going to contribute to death. So again, I'm not saying a pack of spinach is going to kill you, but this is how detrimental these compounds are within the body. So when we listen to, not that we do listen, but when Layman Norton and people will suggest that these oxalates, don't exist and they're not damaging, an abundant amount of studies that will show the opposite. And I have actually seen a study which has shown as little as 3,000 milligrams causing death. So pardon the pun, but it gives us some food for thought. So let's go on to kale really quickly. So kale is high in flavonoids, and they boast this as if it's a good thing. Kale is particularly rich in flavonoids, especially quercetin. Fantastic. where are we? Kale, on this one. Yes, quercetin is an endocrine disruptor. So wait a minute, they were just saying the quercetin is a good thing, but it's an endocrine disruptor. Quercetin can decrease the expression of genes that result in restriction to the thyroid, including thyrotropin receptor, thyroid peroxidase, and thyroglobulin. Quercetin can also decrease iodine uptake within the thyroid, which suggests thyroid dysfunction. So this is what quercetin does. And yet we're told that quercetin, for example, is found in things like kale and onions and so on and so forth. We're told that these are beneficial. These are endocrine disruptors, which means they damage and upset the hormone balance within our body, which we do not want. So on one hand, they're boasting that these confer a benefit, but yet what these studies actually indicate is that they are detrimental to our health. Phytoestrogens, which are found in soy products, phytoestrogens, they present hormone-like activity, and they will create phytoestrogens and compete for estrogen, and they can increase estrogen and lead to a whole host of problems in both men and women. And this isn't just the phytoestrogen, this is all flavonoids. Flavonoids are groups of polyphenols, and we've heard many mentioned, within the social media and on TV. Narinogen, for example, is meant to be incredibly beneficial. But these isoflavones are digestive inhibitors, and they block the absorption of vitamin C, which causes a reduction in net protein utilization. Now, we're told the kale is high in vitamin C, but the issue with this is the flavonoids within there actually prevent, and this is what the bottom thing references there, the flavonoids inhibit the absorption of vitamin C. Now, kale is incredibly high in vitamin C. Kale contains more vitamin C per 100 grams than citrus fruits, and it's around 93 milligrams per 100 grams. But the flavonoids found within prevent the body from actually being able to absorb the vitamin C. So when we believe that we are obtaining adequate amounts of vitamin C from our kale, then we are not, because this is what the quercetin and other flavonoids actually inhibit. Now, these flavonoids, they also cause infertility in both men and women. They activate the 17B estradiol receptor, which blocks thyroid peroxidase, which we need to make thyroid hormones. So again, coming back to this HPA axis that we've just mentioned, it can lead to hypothyroidism in women and gynecomastia in men. And they also increase inflammatory markers, interleukin-1, 6, and tumor necrosis factor alpha. So these compounds, genistein found in soy, quercetin in onions, and anthocyanin in berries, and so on and so forth, these are damaging endocrine disruptors which cause damage to our DNA. They have these genotoxic effects, and they affect the way that the body works on a daily basis. Even when it comes down to seeds, for example. So these are flax seeds. Now, we're told that these are an incredible source of omega-3s, but they are not. Seeds contain ALA, and the human body needs EPA. The human body needs episopentanoic and doxahexanoic. We cannot get these from seeds. The body needs to convert ALA into EPA, and it does so inefficiently. The study suggests close to zero is actually converted. But what these seeds do actually contain is cyanide. They contain hydrocyanic acid, which breaks down into cyanide within the body to a deadly amount also. And this isn't something that is historic. This isn't something that has happened a long time ago, which doesn't happen in modern day. This thing occurred, this study or paper came out in 2017, and it references 2 deaths from cyanide consumption from cassava root. Where was it? It was in Africa somewhere, wasn't it? In Uganda. So, 33 people with symptoms include diarrhea, vomiting, and abdominal pains, and it resulted in 2 deaths. 98 cases were eventually referenced. So this occurs in modern time. And if we look at the level of toxic cyanide that are found within these compounds, we find that they are cumulative, which means that it's not just enough to say, well, I only have a little, because there's an accumulative effect. And what this study highlights is that if we consume some now, some later, some again, and so on, this accumulation occurs within the body. Now, for full disclosure, the top range there is referenced as a potential toxic threshold. And the person that reached this in study did not suffer with any ill health. He didn't notice any effects whatsoever. So for full disclosure, that's what happened. But this individual was super fit and healthy, no underlying health problems. But I would argue that if he continued to do this every day because of the cumulative effect of the cyanide, that it would lead to a lethal dose. And we know that the lethal dose is between 0.5 and 3.5 milligrams per kilogram, which basically the lower end of toxicity for cyanogenic glycoside within the human body is 0.5 kilogram. So basically, if you weigh 70 kilograms, 35 milligrams of cyanogenic glycoside is enough to kill an adult human being. And a pack, I got some, I may even have some on my desk. Flaxseed. Now, if you were to put this into a blender and blend this, and it does have to be blended, so it does need to, we do need to break the skin and release these compounds. So sometimes just swallowing wouldn't be enough. But this is what I used to do. I used to add my spinach and kale with my turmeric and black pepper and my flax seeds to my smoothies every day, thinking I was being fit and healthy. But if you ground all of this, this is potentially enough to cause death. Now, the argument would be, well, I'm not going to use all of this pack, but bear in mind it is accumulative. And also bear in mind that it's incredibly easy to overconsume these compounds, especially if you're baking bread and adding them to smoothies. But what I would argue is that if this was enough to kill you in one go, and I told you it was going to kill you, would you consume it? And the answer to that would probably be no. But then if I was to offer you this much, of your favorite beverage, and I added rat poison to it, would you drink that beverage if it contained the rat poison? And the answer is going to be no, because it contains rat poison, even though it's not enough to kill you. But this is what we do on a daily basis when we are consuming these toxic compounds, like the cyanogenic glycosides and these isothiocyanates, which at a genetic level are damaging our DNA. And it's even the case when we look at apple seeds. So apple seeds contain another cyanogenic glycoside called amygdalin. And it goes on to say that hydrocyanic acid is highly poisonous and can be fatal if enough is consumed. But the amount of cyanide in apple seeds is not enough to kill someone unless they eat a large amount of crushed seeds. So what do we class as a large amount? A lethal dose, again, 30 to 300 milligrams, as this 28 analysis discovered. But an apple seed contains, let's break that down. It basically highlights that we need 83 to 500 apple seeds. So let's go look at the lower limit, 83. Well, the average apple contains between 6 to 12 apple seeds. So this is like 6 to 10 apples, potentially. Now, that does sound like an awful lot of apples, but I used to add 2 apples to my smoothies every day. When I was adding, and I thought I was being super fit and healthy, I'd put 2 full apples in my blender. I'd add in my cyanogenic glycosides, my flax seeds and my kale and black pepper and so on and so forth. And I would consume this every day. Obviously, it didn't kill me, but the potential was there. Now, if I was coming from, super unhealthy background, when I was consuming this, I was gravitating into changing my lifestyle. But even still, this allowed me not to heal and repair my body. And this is why I ended up gravitating deeper into becoming ketogenic and carnivore. But what scares me with this is that many of us think that we're being healthy because we're blending these apples and these brown flax seeds and so on and so forth. And then we give them to our kids. We make up a portion of this and we hand this to our child. Now, bearing in mind 6 to 8 apples, crushed apple seeds, is potentially enough to kill a grown adult human being. But how much is likely to kill a young child? Well, it's going to be a fraction of this. And this is what scares me when we see these people on the social networks who are blending these apples and these brown flax seeds and giving them to children. This is toxic. This contains cyanide, is one of the most damaging compounds on the planet. And cyanide also damages DNA. All of these things that we are told are completely healthy and ideal for epigenetics are actually causing damage to our genome. These are the compounds that are causing this damage, this genetic damage to our DNA. And then I've got a little bit in this. I'm conscious of the time, and this was a little bit about antioxidants. 22. Let's go into this really quickly because I think this is important. Now, antioxidants, we're told that things like turmeric and black pepper are good for us because they create a hormetic response. And we're told that they're antioxidants, but they're not. These are in fact pro-oxidants. And you guys have already mentioned this a number of times, but in simplistic terms, there are 2 different types of hormesis: environmental hormesis and molecular hormesis. Environmental would be working out in the gym, training, cold water therapy, red light therapy. These are real states of hormetic responses, but these are environmental. Molecular hormesis includes the modulation of the transcription factor NRF2 pathway, which you guys have already mentioned a number of times. But it's believed that the activation of this pathway will confer a benefit, but it doesn't. And the reason that we should see it in the short term is that when we activate this pathway, it can elicit a response via glutathione, which is the body's master antioxidant for the short term. But then we continue to consume these products, and this will lead to an overexpression within this pathway. And then this will activate another pathway called NF-κB, which will lead to a whole host of toxic and inflammatory cytokines, which cause loads and loads of problems. So we know that, and let's click it back. Let's go on to this. So it clearly says with this, cruciferous vegetables such as broccoli, cauliflower contain sulforaphane, which activates the NRF2 pathway. So that sounds fantastic. Well, am I lying to you? Am I lying that the activation of this pathway is detrimental? Well, let's find out. This is a quick Google search. Lead exposure can activate the NRF2 pathway. Arsenic can activate the NRF2 pathway. Mercury, tobacco smoke, exhaust fumes, all of these things will elicit the same response as you consuming vegetables. And that is without question. And we've just seen from that study that these vegetables will activate the NRF2 pathway. If you were to go and suck on an exhaust fume, you will elicit the same pathway response as eating vegetables. So next time you think, you ever question this lifestyle and think, well, carnivore's a bit extreme, maybe I do need to put in some vegetables. And I'm not telling you not to eat vegetables. I just want to arm you with the knowledge to enable you to make an educated decision. This is the pathway that these compounds elicit. It's the same pathway as lead, mercury, arsenic, tobacco smoke, and so on and so forth. And this goes on and on. We look into the effect of, also, in fact, glutathione. This is why we believe that this NRF2 pathway is beneficial, but it's short-lived. This activation or elicitation and elevation in glutathione via the NRF2 pathway is short-lived, and it quite often drops below baseline incredibly quickly, which is not a true hormetic response. A true hormetic response via environmental impacts is where we would see an elevation in glutathione, and glutathione would stay elevated for a prolonged period of time, i.e. a number of days. And this is what cold water dipping and red light therapy and training in the gym do. This pathway isn't activated in the same way when we consume vegetables because it spikes and then it crashes soon after below baseline. That is not a true hormetic response. But how can we increase glutathione? Ketosis, living a ketogenic lifestyle, a carnivore-based lifestyle, will increase glutathione naturally. And you guys have heard me mention with Steve and Dr. Abs on a number of occasions how beneficial glutathione is. Just the human body creating ketones will elicit this elevation in glutathione, which is the body's master antioxidant. Living this lifestyle is the best way to fight off these viruses and infections and help the body combat these external factors that are damaging to the human body. And then we look into things like green tea, for example, and this study is an incredible one, and we can get into this in more detail in context just on this one thing. But the overall effect of this 10-week study basically showed that dietary fruits and vegetables was a decrease in oxidative damage. So when they removed the green tea, vegetables and fruits, they saw a reduction in oxidative damage to DNA, which again just adds more weight to the fact that green tea and these fruits and vegetables cause damage, again, these genotoxic effects, damage to DNA via clastogenesis. And again, as we know, coffee is the same. Coffee contains a compound called acrylamide, which is a known carcinogen in the state of California. And in 2018, this was hit with a Prop 65 warning, which basically meant that coffee shops selling coffee had to put a warning on saying this contains acrylamide and may cause cancer. They went to court and had this overturned, but the fact they had to put it on in the first place should give food for thought. I won't bore you too much with acrylamide because me and Stephen go into this a lot, and I'm almost done, and apologies, we will have time for Q&A. But taking a step back, we've just mentioned that expressing the DNA, our epigenetics, is the best way to flick the switches and activate our DNA at the highest level to allow us to achieve things that maybe we couldn't normally. And now we've looked into the foods that do not allow us to access and express our DNA. Fruits, vegetables, green tea, coffee, so on and so forth. So what does allow us to increase this genetic response, this epigenetic response? What does allow us to increase the things like, these are the studies about the acrylamide. what allows us to increase the telomere length on these chromosomes. And for those of you who don't know, the telomeres are the ends. These are like the caps on the ends of our chromosomes that allow us to allow us to heal and repair. These are directly correlated with longevity. And there's a little write up there. And the shorter the telomere length is basically correlated with shorter lifespan. So the longer the telomere length, the longer we have to live. Every time the cell divides, the chromatin and the telomere length is reduced, which we don't want. And this is what these compounds cause if we consume fruits and vegetables and so on and so forth. And there's one thing that has been recognized through a number of studies which will actually increase the length of the telomeres, and it's red meat. Red meat is the one compound on the planet which has been shown to increase telomere length. And this study wasn't alone. Study after study after study has shown that eating animal proteins, particularly red meat, increases the telomere length. This actually increases the protective compound on our chromosomes, which protects our DNA. Red meat protects our DNA. Red meat allows us to tap in and express our DNA at a level that the vegetables can't. And I don't want to bore you too much of this, but there is one other thing that I wanted to show you. And it comes on to this, basically ketones. Ketones also allow us to balance neurotransmitters in the brain, glutamate and GABA. And I won't bore you with this too much, but these are neurotransmitters which are really important for mental health and longevity. But they also help increase the HATs, the histone acetyltransferase. So ketones, they allow us to express our DNA at a genetic level, at the genome. And this is what the study highlights. The ketone bodies inhibit histone deacetylase. So they inhibit this compound, leaving the HATs available for expression, basically allowing us to open the chromatin. So what that tells me is that if I want to be the fittest and healthiest version of myself, if I want to express my DNA to enable me to do this, then I need to avoid broccoli, spinach, kale, green tea, coffee. And I know many of you are coffee drinkers, and I'm not going to tell you guys not to drink coffee, because until recently, coffee was my life. This is an incremental journey, and I'm not there to tell you not to drink green tea and so on and so forth. But all I want to do is arm you with the knowledge, because if you can just remove one of these things, if you will live in a ketogenic lifestyle and you're toying with the idea of maybe gravitating deeper into a carnivore journey, and maybe this is the lever that you can pull that will allow you to make that transition. Maybe you'll just remove the broccoli, or maybe you'll reduce the broccoli. Maybe you'll take out the kale and spinach and so on and so forth. But maybe the coffee you'll keep in. But everything else is still allowing you to pull all of these extra levers, which is allowing this expression of the DNA, allowing you to access your DNA via epigenetics, allowing you to thrive in life, not just to survive, but thrive. And this is what being ketogenic does. This is what being carnivore does. It increases these ketone bodies, which allow us to increase the glutathione, balance the glutamate and GABA ratio, and block and inhibit histone deacetylase, which is what causes the chromatin to become closed and unavailable for expression. And look, there's lots more to go in there. I don't want to keep on going on because we've got like 12 minutes left. I'm happy to go over a little bit more, but in simplistic terms, it's living this lifestyle that allows us to access our DNA. And in simple terms, this is what epigenetics is, and this is how we express it. Live in a ketogenic lifestyle, live in a carnivore-based lifestyle, consuming animal products with natural fats, eat as nature intended. Nature provides us with this perfectly packaged present. Everything in nature from the animal kingdom comes with protein, comes with fat, and almost in equal amounts. And what do we do in our wisdom? Thinking that we know better, we take that chicken breast and we take the skin off. We remove the fat because we believe it's detrimental. Nature provides us with this perfectly packaged present in the perfect entity and quantity that we need. And we come along and we strip the fat. We need protein and we need fat. Eat as nature intended while trying to limit and negate the detrimental and toxic effects of these other fruits and vegetables and so on and so forth. But again, just to reiterate, this isn't I don't want a dogmatic community. I don't want a community or a group which looks down and frowns upon people who eat dark chocolate or drink coffee or drink tea or consume broccoli. We're all on our own journey. All I want to do is arm you guys with the knowledge so you can make an let's spit it out, an educated decision every day on a daily basis. And I will never tell anybody that they should not be eating chocolate or broccoli and so on and so forth. I just want to give you the knowledge to make these educated decisions. And in my opinion, what I've just told you is the best way in order to do this.
Well, that was brilliant, Richard. I'm glad we recorded that, and we've also got a transcript, which is amazing. We do have some questions. So I think actually just going back to the question that I mentioned at the beginning of the program was about the set point. I think you answered it, but do you want to, now you've done that presentation, answer that? Because many people seem to think we have a weight set point or a fat set point, and we get rigidly stuck to that. What do you think then?
So look, I think there's an element of truth to it, but I think it's something, again, that we cling on to, especially in the same way that we blame our genetics. It runs in my family. Well, you eat the same foods that your family eat. Maybe if you ate something different, then you would, attain a different result. So look, to think about that logically, let's take a step back and think, does the average person gain weight with age over time? And I think the answer to that question is yes. Most of us, as we age, we get this middle-age spread, and we put it down to life. We gain weight as we age, and that's just a fact of life. So if this set point was correct, then we would stay the same weight, most of our life, but we don't. And this is because we consume toxic compounds like carbohydrates and seed oils, which elicit an insulin response and basically tell the body to store fat. Again, they break the bonds on the glycerol backbone and send fatty acids into the fat cell. Now, when you gravitate into a ketogenic or carnivore way of living, we don't elicit this response. And this generally allows us to lose weight because we need insulin to store fat. And when we gravitate into this, many of us will lose a lot of weight. We see people constantly, I'm down 7 pounds, I'm down 10 pounds, I'm down 15 pounds. And some of this is water, but we are burning fat because when we live this lifestyle, we are fat burners. But that said, what happens eventually is you hit a plateau. And with the best will in the world, nothing changes. And you try everything. You increase the fat, you lower the fat, you try exercising more, you try all of these things and nothing happens. Now, that image that I showed you in the presentation, that didn't happen overnight. It took me 4 or 5 years to create that. And what I found during my journey is that with the best will in the world, I was only ever able to achieve the lowest fat percentage at any given time for a period of time. And the reason for this is that the body will find a natural level of homeostasis that it wants to live and thrive and survive in, something that it deems to be safe. And if we were to heavily reduce the amount of food that we eat, for example, then the body may prevent us from losing that because it believes we're going into starvation. And so it will basically bounce between a range. But there are levers that we can pull. Now, when I say what I'm going to say, I'm going to reference share trading, so the stock markets, which is something that I used to do. And one of the things that you used to do was you used to look for resistance and support. So if you think of 2 lines and the stock price bounces between these things, so the bottom line is support and the top line is resistance. And what happens is when it comes down, which is the resistance, it bounces off and it comes back up and it moves between this in this sort of fashion, in a wave sort of fashion. But there's a rule within share trading that basically says that once it's hit it once and it hits it again, on the 3rd time, it breaks through. And this resistance or this support then becomes resistance. We break through this, and then this becomes the upper limit. And the human body works this way also. Once we break through this plateau, and there are ways and means to do this, and it is very much an individual approach. Once we break through this, then we function between another set range, if you like, an upper and lower limit for a prolonged period of time. But if we give the body everything it needs, and more importantly, if we abstain from the compounds that we don't want to consume that are detrimental, then we can further break through this resistance again, and we can drop to the next lower level, and we can constantly drop through these levels, changing the range that we move in. So that image that I showed you where I was like 3% body fat, it took me 5 years to get to that. Now, the first year, first 12 months of being super strict got me into maybe like 12% body fat, which yes, that's quite low, but I'm less than 12% now. Like, I don't think I'll ever see 12% with all the will in the world, because my body has now become accustomed to my lower range being sort of between 8 and maybe 11%. So even though, I don't do an awful lot of training, you guys think that I run hundreds of miles a week. I run like once a week generally. and it's only like 6 miles. I'm chained to my desk constantly. I consume lots and lots of food, again, probably between 4 to 6,000 calorie equivalent. Yet I don't gain weight. I'm still I'm around single figure body fat. So it bounces between 8 to 11%. But that 12% in the initial year, with my best will in the world, that was the lowest that I could achieve until I functioned within that range for a prolonged period of time. And my body was happy. Yeah, we can function in this zone. We're safe, we're fine, we've got an abundant store of body fat. The owner, the guy in the box is pushing the button to break through this resistance. Let's do it. We can afford to go to the next level. So my point to this is time is key, and there are things that we can do. And if you ever doubt this, back to, think back to the camps. What's the word I'm thinking of, Steve? Concentration camps.
Yes.
You never see an overweight person there. They were heavily starved. They didn't maintain their weight, because eventually the body began to eat itself. And that's what we have the ability to do, but we have the ability to do it naturally and through a non-sort of forced means. And what I mean by that is, if you were to reduce the amount of food that you're eating, the average person on the high street will tell you that you're starving yourself. We are fat burners. Now, we store fat for a reason. We store fat for us to use for energy at a later date. But for many of us, that later date never comes. But now it's here. Now we're living this lifestyle. We can use this. So all we need to do is flip the switch from dietary fat into stored body fat. And as we become fat adapted and keto adapted, this happens seamlessly. Yes, we may feel a little bit hungry, but when we know which levers to pull and when to pull them, we can upregulate body fat oxidation and we can lose weight. And there are ways to do this. Meal timings are important. Cortisol management's important. Making sure you don't overtrain. And I know that, there are people out there who have tried increasing their caloric intake, their fat consumption, reducing it, and so on and so forth. But quite often, we don't try these things for long enough. And there is a protocol to follow. And we can get into this maybe next week into a bit more detail, because I'm just conscious there are lots of questions. But look, it doesn't matter who you are, where you are on your journey. There are always levers to pull, and that goal is never an unrealistic goal. If you want to be a certain percentage body fat, you can manipulate these levers and achieve these things. Whether it's actually healthy for you to get to that range is another question. But generally, 18% for women and around 12 to 15% for men is regarded as being a healthy range. I'm no longer ripped and shredded with abs. I've got abs if I really tense and turn to the side and the sunlight hits it. I don't look like this anymore, but I'm healthier. So my body wants to retain a little bit of fat. Think of the Tarzan films. Think of Tarzan back in the old films. He wasn't ripped and shredded with veins running through his abs. He was just fit and healthy with sort of washed out type abs, if you like. So that image that we see in the magazines of that woman who is super ripped and shredded and that guy who was ripped and shredded, these I don't want to say unrealistic because you can achieve anything, but these are not naturally occurring generally. Many of these people have been heavily supplemented and they go through prolonged periods of time of heavy dieting, which is detrimental for cortisol and thyroid function. And my point to this is, yes, you can achieve these with diet and lifestyle by pulling the correct levers, but do we want to get to single figure body fat? And the answer, in my opinion, generally is no, unless you're competing. But how we get there, again, is different for everybody. There is a standard protocol that I tend to roll out to clients when I do coaching calls, and we can get into this. I think it was Gary that asked that question, Steve. Was it Gary? I think we can get into this maybe on the next call, because it will take another 10 to 15 minutes to run through the protocol. But just rest assured, there are levers that we can pull. Consistency is key. As long as we keep pushing forward, then we can and will achieve the goals that we want to, providing we're willing to do the things that it takes to get there. Does that make sense?
Yeah, it makes total sense. I mean, it's one of the things I say a lot about genetics is, people lose weight. We didn't change their DNA. We just changed their diet. I mean, it's really that simple. People reverse type 2 diabetes. They didn't change their genetic makeup, did they? They just changed their way of eating. So we've got lots of proof. There are a couple of questions. we're supposed to finish at 9. I'm due to do a coaching call in about 15 minutes or less than that now. So we're going to have to be quick, really. Although those questions we could do another day. But Matthew's asking, what are the positives and negatives of drinking ginger root tea? Apparently, it's good for the liver and increases testosterone in men.
But look, we'll blitz through some of these as quick as we can through Steve. Look, there's again, when these compounds, these plants make medicines, and I'm not anti-medicine. If it wasn't for medication at several times or points in my life, I would be dead. So when we consume things like ginger or turmeric, for example, and people will say to you, well, I took turmeric when I was inflamed and it worked. And it can work because they're medicines, they're medications. But the key is that we're not designed to take medication on a long-term basis. This is why the pamphlet that comes with your medication says that, it's got a huge list of potential side effects. And quite often they include death. So its medication is there to be used in the short term. So if you were suffering with an issue, ginger can be used as well as licorice root and so on and so forth for cortisol healing. So if we have damaged the HPA axis, these are things we can use to allow us to confer benefits in the short term. But the key to this is the short term. It elicits this response via this pathway that I've just mentioned, which is the NRF2 pathway, which will increase glutathione in the short term. So it can help block inflammation, it can help with liver function, and it can help with all of these other things that we see the studies claim to make. But what happens is once we overexpress this pathway, then it triggers another pathway. All of these things stop, and now we become more inflamed. And in fact, if you were to continue to consume ginger root tea long term, it's quite possible it would lead to liver damage. Same with licorice root and so on and so forth. All of these things, they're designed for short-term medicinal purposes. And I'm not against these. I think plants do have their place for medicinal places, and we've seen it through the entire evolution of man, through almost every corner on the planet. Different places on the world will use different teas and different substances to heal and repair in the short term, but they don't go on to continue to consume these compounds long term. So yes, there are benefits, but long term, it's going to undo all of the work. It will lead to liver damage, and it can even affect testosterone negatively in the long term. What's testosterone made out of? Testosterone is made of cholesterol. So, the key to this is avoiding the compounds that lower cholesterol, i.e. plant sterols, increase your saturated fats, increase your meats, and you'll increase testosterone naturally. But again, what is an optimal range for testosterone to work in? We all have different ranges. Just because the range says that we should be within this, it doesn't mean that you have to function. You're going to function better with higher testosterone. You may be functioning a lot lower, a lot more efficiently. The thing that I always say to this is think of insulin. If you were to test my insulin or your insulin is going to be low. Does that mean that you have an insulin deficiency? Does that mean that you have a problem producing insulin? Well, no, it just means that the amount of insulin that your body needs to produce is lower because now it's more effective because you're no longer insulin resistant. So think of that with testosterone. If your body works more efficiently, then it needs this amount of testosterone to create this amount of work, opposed to this much when the body's damaged. And it's the same when we look at thyroid function, for example. Women heavily concerned with thyroid function. Let's look at plant compounds which contain vitamin A, beta-carotene. Now, in order to process beta-carotene and convert it into retinol, we need T4. It takes T4 to convert beta-carotene into retinol, which basically means it depletes T4. Now, if you have less T4, that means you're going to produce less T3. So what happens if you're consuming lots of fruits and vegetables and your body is required to convert this beta-carotene into retinol and your thyroid is damaged? Well, now you're causing further damage and restriction to T4, and the downstream effects of T3 are affected. And also, you're not actually absorbing any of the beta-carotene as retinol. Well, meat contains retinol. So why don't we just remove the plant compounds? Now we need less T4. So T4 levels may be lower because we require less to carry out the same amount of work. And now we need less T3 because now we're no longer consuming carbohydrate. And T3 is used in the pyruvate, the MPC, the mitochondrial pyruvate complex. We need T3 to process carbohydrates. So now T3 is lower. So does that mean we've got a problem? Well, no, because the amount of T3 and T4 that's being produced is a sufficient amount to carry out the work that is required. And it's the same, again, with testosterone, all of these things that we see within the body. So again, things like ginger root tea, they can confer a benefit in the short term, same as turmeric if you are inflamed. But I would suggest using these compounds for a couple of days and then coming away. The key to this is looking at the root cause. What's caused the problem? What's caused the problem? Fix the root cause, and then our requirement for these compounds is no longer there.
Yeah, brilliant. I mean, just very quickly, ginger is very good for stomach upsets on a very brief journey on sea, for instance, and it was always used in the Navy, and it does work. It's very long-term use is not recommended, exactly. And also it is a blood thinner because it interacts with medication. So if someone, and I know this because for phlebotomy, if people have lots of ginger and they tell me on the health and activity form, then you'd say, well, right, okay, that has been thinning your blood, so that will make a little bit of a difference. So there are all these side effects, definitely. Helen's got a question. When my mum was going through her chemo treatment, she took B17, Dietary treatment, I think that's how you pronounce it, by the way, which is the cyanide found in apple pips and apricot kernels. The Hope Hospital in Mexico does this treatment to kill cancer cells, but without killing other cells in the body, as chemo kills all cells. Have you heard of this treatment? Yes, I've heard of this treatment. I had an argument with ChatGPT over it, actually, many moons ago. Yeah, so Helen, your mum tried it. How did you get on? Did you get on okay? Yeah, right. Well, that's my argument. The problem is, talking about this, if you go on Google or if you do any sort of search in the West, they are absolutely anti anything outside of FDA-approved treatments, and you will just get a torrent of abuse. ChatGPT, even if you keep pushing and pushing it, which I did, and I eventually got some sort of contrite, well, yeah, maybe it works, but it's anecdotal evidence and it's not scientific vigor, all right? I had to tell ChatGPT that I lost my dad who was on treatment because basically he was saying the mainstream mantra is it's safe and effective, all right? Well, I queried the effective because my dad was dead within a week of it from cancer of the spine, and my mother was in and out of intensive care for many years. I don't call that effective. 11 years of living, well, a disease span of 11 years, not a lifespan. So even with that information, it was like, oh, yeah, well, they're anecdotes, but really, generally speaking, they're safe and effective. Well, everyone I speak to, it isn't safe and effective. So anyway, yes, that's what I've heard of it. Have you heard of it, Richard?
Yeah, and again, look, it comes back to all of these. There are lots of other compounds which can cause damage to cancer cells. Cyanide will upset every other cell in the body. To what degree? But look, it's all of these things work. You know, the sulforaphane from broccoli works. It is a chemotherapy treatment, and we see people who have success, you know, within this. I know someone who has successfully had chemotherapy treatment and been, you know, fantastically fine. So these things do work. They do kill cancer cells, but again, I would argue that, you know, these other things do kill human cells within the body. But the answer to this is stop consuming the fuel that feeds the cancers. And we know, you know, this. I did a podcast recently with Professor Seafeed, who, in my opinion, is world number one on metabolic cancer treatment. His studies are staggering. You know, we know that glucose and glutamate fuels cancer cells. So if we stop consuming these, you know, we can, in most cases, in 95% of cases, we can stop cancer dead in its tracks. I've worked with 2 cancer patients. One was both had chemotherapy and failed. The woman that I worked with had breast cancer and continued with it with a second round of chemo, but went keto, and that worked. So was it keto or was it the chemo or a combination? You know, I believe it's a combination, but fantastic. The young boy that I worked with, who is connected to someone who works in Premiership football, he came to see me. His nephew had Ewing sarcoma, which is a type of bone cancer in the legs. Tried chemo, did not work, and we put him on a carnivore lifestyle. 3-4 years later, he is still cancer-free without chemotherapy treatment. So the chemotherapy failed, and then ketogenic and carnivore worked when nothing else did, and he didn't have to put toxic compounds in. So we can always make an argument for all of these things. Which is the most effective? I would argue removing the compound that causes them and fuels them. And we know this is glucose. We can't remove glutamate because glutamate is essential for many processes. But this tends to happen further downstream. The glutamate that fuels cells tends to happen after the cancer has developed to a certain point. And if we catch it early enough, and this is incredibly difficult when you're trying to explain to someone or a loved one that, look, stop eating this and you'll be fine, or, at least continue with the medication, but do this also, because their doctor in most cases will tell them that, you're wrong and your body needs sugar and glucose. But we within this community know that is the best form of cancer treatment. And I won't get into what causes and fuels cancer now, because we'll be going off on another 20 minutes to 40 minutes. But yes, all of these things work. We know cancer treatment works, but cyanide is one of the most toxic compounds to the human body. For anyone to argue that cyanide doesn't damage other cells, it does. It damages all cells. It damages DNA. And I would if I did develop cancer, I would consider all options. That said, and touch wood, I genuinely think that I will never develop cancer, because I don't consume the compounds that are going to elicit that response. But, if I was living a standard lifestyle, I'd remove carbohydrates, I'd remove the seed oils. I may look into sulforaphane from broccoli, potentially broccoli sprouts. But now, knowing what I know now, I would just gravitate into being a strict carnivore, and that is the key to me, I think, is nutrition's key. All of these things work, and I'm not here to put any other treatment down, but I do believe that this way of living is definitely the best and most effective treatment, whether it's in conjunction with other things or not. But cyanide's a toxic compound.
I think the B17 is amygdalin, actually, which anyway, we'll talk about that another day. I have got to go. We've got to go. So thanks everyone for tuning in. I'm going to stop the recording now and the transcript, and it will be available for playback.